Okay, in this video, we're going to take a look at how to analyze situations where the motion of the object will not be horizontal or vertical. It will be on an incline of some sort. Another thing we're going to see here is another example of algebraic substitution. So here's the situation we're going to work with. We've got a crate sliding down an incline or a ramp where the ramp is inclined at 34 degrees and the coefficient of friction, the roughness factor between the crate and the ramp is 0.3. All right, well, I'm going to decide this is a forces problem because we want to know about the acceleration, which could be either motion or force, but what we're given is information about friction, and so that's going to be more likely a forces problem. Therefore, I'm going to draw a free body diagram. I have my normal force, ramp on crate. I have earth on crate, and then I have friction, acting back up that way, friction, ramp on crate. Now, in order to keep things simple motion-wise and to some extent mathematics-wise, we are going to want to do an axis system that's a little bit different than what we've done previously. Instead of making a horizontal and vertical axis, we're going to make an axis where one of the axes, let's call it the y-axis, runs perpendicular to the incline, and the other axis runs parallel to the incline. What's the reason for doing this? The reason for doing this is twofold. The first is that this way the object stays moving along one of the axes and keeps it into one-dimensional motion. That will make any subsequent work a lot easier. Secondarily, for reasons that we're not going to get into, the mathematics is a little bit simplified if we do it this way. Actually, one quick reason why is that two of the forces lie along these axes, whereas only the weight vector does not. And that'll make some of our right angle trig work be a little bit simpler. All right. Well, if we're going to set up some net force equations, forces along the x and y axis, we can go ahead and do that. So along let's do the x-axis here. Force along the x-axis equals. So what is along the x-axis? Well, in the negative direction, we've got friction, ramp on cart. And in the positive axis, we have the weight, but not all of the weight. We just have a portion of the weight which is directed like that. We'll call that weight to the earth and the crate, but only the x component. And of course, similarly, we have a weight earth on crate y directed down that way. All right, so this is going to be plus earth on crate x equals max. We'll call that positive and that negative. So there's the x equation. Let's see about the y equation. The y equation looks like this. Normal force, ramp on cart, minus earth on cart, but only the y component, and that should equal may. Now I want to walk through what my next steps will be before I actually carry them out. The first step that I'm going to want to try to do is find the components of the weight. Once I do that, I'm going to sub in for the friction force and also do some subbing in for the weight. And then 3, I'm going to find my acceleration down the ramp, which will be the horizontal acceleration. We'll do that in the next segment.